Vectors and solving triangles. What we want to do now is calculate the actual speed and direction of the airplane, and this involves taking vectors and adding them together. So we have an airplane at 105 degrees at 215 miles per hour, and we have the wind blowing at a direction of 42 degrees and 23 miles per hour. So the first thing we want to do here is to redraw our picture so that we create a triangle and show the resultant vector, which is going to be our actual speed and direction. Remember, when you add vectors, you connect them head to tail. Also, remember the direction of a vector is measured counterclockwise from the positive x-axis. So here we have our two vectors added together. Now we add the resultant vector. This represents the actual speed and direction. Here's what we know. We know that the wind is 23 miles per hour and the airplane is 215 miles per hour. If we add some auxiliary lines, we can figure out some angles that will help us move on. So we add a line at the bottom and a line at the top of our airplane vector. And remember, these are parallel lines. So these are parallel lines and they are cut by a transversal. The airplane vector is a transversal that's cutting through these two parallel lines. Again, the things that we know. The airplane vector has a direction of 105 degrees. So 180 minus 105 tells us that the angle on the opposite side is 75 degrees. Now, because that airplane vector is cutting through two parallel lines, we know that we have 75 degrees on the alternate interior angle. We also know that the wind has a direction of 23 degrees, or sorry, 42 degrees. So we put some labels on here, angle A, angle B, angle C, and then their opposite sides. Side A is 23, side C is 215. Side B is what we're trying to solve for. The measure of angle B, with what we've just learned, is 42 degrees plus 75 degrees, which equals 117 degrees. So now we have side angle side. This allows us to use the law of cosines to find B, which is the actual distance or speed. B squared equals A squared plus C squared minus 2AC cosine of B. After substitution and solving for B, we find that B is approximately 226.37, which is the final actual speed after the vectors are added together. Now we have all three sides. We can use the law of sines to find the measure of angle A. We don't need angle C or side C here, so we're going to substitute for the side A is 23. Sine of angle A equals 226.37, which is side B, over sine of 117. Again, solving for A, we find that angle A is approximately 5.19. Be careful though. Angle A is approximately 5.19 degrees, but we are not done yet. What we are looking for is the measure from the positive x-axis to our resultant vector. The last step is that we need to subtract 105 minus 5.19. And when we do that, we see that our final answer is an actual speed of 226.37 and an actual direction of 99.81 degrees.